Hi, I'm Veli from Greenwood Solutions. This week we're looking at heat pumps. So after the presentation, you'll understand what a heat pump is, how it works, and how does it compare to other methods of heating and cooling. Now, if you like what you see, hit that subscription button. Okay, ready, steady, go. A heat pump is a standalone two-component appliance which uses refrigeration technology and electricity to provide heating, cooling, and/or hot water. The main components effectively are broken down into two. A condenser unit that most often sits outside of a house that produces the heating or cooling, and an indoor unit that typically sits on a wall and passes hot or cool air into the home. Basically a reverse cycle air conditioner. Also, there is hot water heat pumps, which have a water storage component. Well, they extract heat from the air outside of your home, then transfer it to a refrigeration coolant, and the coolant is then compressed. This increases the temperature significantly. The coolant is then moved to the indoor unit of the heat pump, and it passes air over the hot coolant. This increases its temperature to accommodate the thermostatic call for heat inside the home. In cooling mode, the process is reversed, transferring heat out of your home and returning cool air to the inside. The refrigerant has an evaporation or boiling point well below zero. Temperatures that feel very cold to us still make the refrigerant boil. Air that has been drawn in is far warmer than the refrigerant and turns the refrigerant from a liquid into a gas inside the heat pump's piping. A compressor pumps the now gaseous refrigerant through a small valve, creating heat. A heat exchanger transfers the heat from the heated refrigerant gas pipes to a tank where water is stored. The temperature of the refrigerant has now dropped dramatically as the heat has been drawn away, so it returns to a liquid state and the heat pump cycle begins again. On and on it goes. So all three systems work exactly the same way. With a hot water heat pump, it extracts heat from the ambient air, sends that heat, pumps it into the water. The water's in a storage tank. The storage tank has an insulative value, thereby maintaining that heat. Since this process merely concentrates existing heat instead of having to create more, heat pumps reduce annual hot water requirements by 50 to 80% compared to electric resistive home systems. Thus, they are considered renewable systems and are eligible for STC rebates in Australia. Now, are heat pumps more environmentally friendly? Well, the answer is yes, 70% more than traditional electric storage systems. Heat pumps decrease more than just your electricity bill. If you switch to a heat pump from a traditional electric system, the pump can lower your hot water heating carbon footprint by up to 70%. So what's the ideal situation to contemplate a heat pump? Effectively, if you don't have roof area for solar panels and your loads are predominantly electrical, this is the ideal situation. Now, because a heat pump actually extracts ambient air and then compresses it, and in that process it releases energy, it does attract rebates and also other financial incentives to go down that track. Now, if you combine a heat pump with PV, you are actually heating your water at a considerably less cost. The amount of heat transferred to the water in the storage tank depends on the surrounding air temperature. Heat pump water heaters are therefore generally better suited to warmer climates and are not well suited to cool climates, especially where frosts occur regularly. In cooler climates, the compressor will run for longer periods, which can result in greater energy consumption and a shorter life expectancy for the pump. So there are some advances in this area where the heat pumps are getting more efficient at lower temperatures, but really at this point in time, from a cost-benefit analysis, if you are looking at a hot water heat pump, ideally you are in a temperate or warmer zone. Now, are heat pumps more environmentally friendly? So if we look at this particular table, we're looking at the heat pump peak tariff and heat pump off-peak tariff. The lowest annual energy cost is from solar natural gas boosted. The next lowest annual energy cost is from solar LPG boosted. And at number 3, a heat pump operating at an off-peak tariff. So now we look at annual greenhouse gas emissions. The system that produces the least amount of emissions is solar natural gas boosted at 215 kilograms. Next on the list is solar LPG boosted at 245. And next on the list is natural gas instantaneous at 845 kilograms per year. So you can see from an emissions point of view that the heat pumps are not even in the top 3. So what size heat pump do I need? Well, effectively, the rule of thumb is count the number of people in your household, assume that each person will use around 50 litres of hot water per day, and this requires that your hot water tank keeps 1.5 days capacity at all times, and multiply the number of people by 75. So for example, a 300 litre tank, storage tank, will suit a family of, say, 4 people in most cases. Obviously that's dependent on how long people take showers and when they use the hot water. This all plays a role. A heat pump is effective even in fairly low temperatures. In extreme cold, an electric assist is activated to ensure the water stays at the desired temperature. No roof space or panels are needed. There's an ease of installation as a solar heat pump uses the same connections as an electric hot water system. There are government incentives involved with the purchase of a hot water heat pump. You're looking at the Solar Hot Water Rebate, you're looking at STCs, and you're looking also at VEECs. So there is financial inducement to go down this road. Conclusion. Heat pumps extract air from the environment, compress it, and then release the energy. Hot water heat pumps are quite efficient when compared to purely resistive electrical loads. Hot water heat pumps attract government rebates. Thanks so much for watching our presentation on heat pumps. I'm Veli from Greenwood Solutions. If you have any questions, any inquiries, any answers, feel free to drop us a line. And if you like what you see, hit that subscription button. Bye for now.